I'm Anna Hoffman, and welcome to this episode of Data Exposed Live. We're super excited to have you joining us here today. We have a really exciting session lined up and some very special guests. So without further ado, I'm going to go ahead and bring up our guests. Our first guest is Alain Dormehl. Alain is on the Azure data team. Alain, thanks for joining us. Can you tell us a little bit about what you do?
Sure. Thanks for having us, Anna. So Alain Dormehl, I'm a program manager on the Azure SQL team, and I look after some of our monitoring tools. And I also have some involvement in some of the back-end pieces that we do for billing and sort of how we sort of get all of that done for customers.
Awesome. Thanks, Alain. And we also have Bob Ward. Bob, you're no stranger here. Thanks for joining us today. Can you tell us a little bit about what you do?
Yeah, Anna, Alain, thanks for having me today. I'm excited to be here. I'm a principal architect in the Azure data team, focusing on SQL. I think I remember last fall, Connor Cunningham telling me, is there anything about SQL you don't do? So I involve myself with SQL from the edge to the cloud, everything you can imagine. And I think famously these days, I'm the person that presents with Anna Hoffman. And also the person, I think the term was, Anna, somebody said legendary. What that meant is I've worked at Microsoft longer than Anna's been born. I think that's the key.
Yes, that is a real true statement. Today we have a lot of exciting stuff planned, but really you guys came to me, I guess a few months ago and said, hey, it'd be really interesting to tell everyone the story of the architecture of Azure SQL. So that's what we're going to be doing today. And for our viewers, if you have any questions throughout this whole thing, please head over to Learn TV. We are monitoring your questions, whether you're streaming from Twitch, Twitter, YouTube, or Learn TV. We'll be monitoring what comes in, but Learn TV is where we'd love to see you guys today. Now, as we kind of get into this content, Bob, I want to start with you. You've been at Microsoft, like we mentioned, since before I was born, and since before Azure kind of existed. So I'd love to kind of kick this off by getting to understand from your perspective, how things have evolved over the years and how Azure SQL has kind of grown and changed and all that sort of good stuff.
Yeah, thanks, Anna. I have to admit, I'm kind of a historian at heart. And I wrote a book called Azure SQL Revealed. And in it, I kind of revealed this little timeline of the history of Azure. Writing that first chapter in History of Azure took the longest chapter of any book in the book itself, because I had to go back and talk to all these people that had worked on Azure so long ago. And I had been at Microsoft since 1993. And if you look at this diagram right here, look at the far left over here, in 2006 is really when this journey started with Azure. Think about that time frame. So that time frame, Windows Server and SQL Server were pretty much really popular. We had just launched SQL Server 2005. The Windows Server team had Windows Server 2003. They were working on Windows Server 2008. These have become very, very popular server on-premises products. And I remember seeing a memo from somebody named Ray Ozzie that Bill Gates had hired to become an architect at Microsoft, that we were going to start embarking on cloud services. And I have to be honest with you, being somebody who worked on SQL Server for so long already at the company, I was like, yeah, what the heck? I mean, cloud services were Hotmail. That's what cloud services were to a lot of people, not running databases and computers. So none of us really thought much about what was going on. What was interesting at the time was Ray embarked the team at Microsoft on two projects at the same time. Red Dog was the code name for Windows Azure, and CloudDB was the code name for SQL Azure. So Ted Kumert, the VP of Microsoft at the time, who I interviewed as part of this book, he embarked on this journey for CloudDB. And then Ray had hired some people to go work on Red Dog. And it's interesting because the funny story about Red Dog is that the team that was working in this was actually in California talking to the Hotmail team and saw a place called the Pink Poodle. What a name. And somebody said, maybe that should be the name of the project for Windows Azure. And somebody said, I don't think that will actually resonate very well. Let's call it Red Dog instead of Pink Poodle. So yeah, pretty funny, right? So
I didn't know that.
You never heard that story, huh? No. Yeah, it's really funny that they did that. So so these teams started. It's interesting though, they were actually on campus at Microsoft in different buildings. They weren't talking to each other, but they were kind of working separately towards the goal. So when we announced in 2008 Windows Azure, we actually called the SQL part SQL Data Services, not SQL Azure. Later, when we actually launched the thing, we would call it SQL Azure. But it was interesting because the fact that we were kind of working in parallel meant that we couldn't rely on each other. And you'll see in a second what I mean by that in an early architecture diagram. Now, I'm not going to talk about everything on here, but I'll talk more about the architectural pieces. So 2013 was really critical because at that time, the Windows Azure team before 13 didn't have a way to have a stateful virtual machine. So all you could do at that time was have stateless. So you didn't have a disk drive, basically. So SQL couldn't run on an Azure virtual machine. And so that was a big thing that we did. And it's interesting that Satya Nadella, now our CEO, had become already the vice president over what we call server tools and business. That's now called cloud and AI that Scott Guthrie owns. And he was a big part of pushing to get that out into the marketplace. Now, a couple of years later, we started between this time frame doing some architectural changes on SQL, Azure SQL, and we call this V12. And we'll talk in a few slides, what was the significance of getting that V12? It was really important because it set the foundation for all this stuff you see to the right of it, including things like elastic pools, eventually something called Cloud Lifter, which is managed instance, and especially these new innovations, Hyperscale, serverless, pools, and then the branding of Azure SQL altogether. So it's an interesting journey because it really talks about the evolution, not just of the product names, but of the architecture itself and this journey between the Microsoft Azure team, and the SQL Azure team.
And also, if you think it's an interesting story that I heard is that if you think about Azure today, it's we have hundreds of services that run today, but Azure SQL in its infancy was actually the very first service we released onto Azure, right? So it has the most pedigree in the cloud from a Microsoft perspective.
It has an incredibly long history, and I think one way for you guys to kind of think about this is to kind of go back and think about the early architecture. So check out this one. Now, for Alain, Anna, you're looking at this, you're like, Bob, could you improve the resolution on this thing a little bit? So you're not going to believe what I found. So this is public information on the internet at that PDC. You ever heard of PDC, Professional Developers Conference? This is a precursor to Build, okay? And this is where Ray Ozzie made that announcement in 2008 about Azure. And by the way, it was a huge announcement. No one knew we were doing this thing, right? So there was a slide deck that David Campbell, one of the original architects in SQL, he doesn't work for Microsoft anymore, but he presented SQL Data Services in 2008 and what they were doing. And this was a slide for the architecture. So the reason why the resolution isn't that great, there's a couple of factors. One, it's a screenshot of something, right, I found. And second, it just shows you the age of PowerPoint. Back in the day, somebody using an older version of PowerPoint, right?
The color selections.
The color selections, exactly. But take a look at this. It's interesting. It's a couple things that stand out on this diagram. This is our early shot at this, right? Now remember, we didn't have Windows Azure as they're building it. We're trying to build, right? So you see at the bottom left-hand corner, the fabric piece. Maybe you've heard that term fabric. Like today, you've heard of Service Fabric, right? Or Windows Fabric. Well, we had to kind of build our own fabric to start with. In fact, not only that, we had to host this, not kind of on the actual Windows Azure infrastructure, but something called Autopilot from the Bing team. Because again, we're all trying to get to market very quickly, right? We knew we were going to go to Windows Azure and get all that going, but we had to get to market quickly. So we're under the Azure umbrella, as Alain said, but architecturally we're using Autopilot to put all these SQL servers out there and VMs out there, and we're building our own fabric. Now behind the scenes though, these are just SQL servers. Now imagine this. This is SQL Server 2005 code we're using because this is 2008. We hadn't even launched SQL 2008 by the time this thing was going, right? So we couldn't rely on that code base. We're relying on the project name Yukon to get this going, which is a great release, but we had to make changes. We had to build our own little fabric here to do things like fault tolerance and scale and so forth. We had to build our own partitioning scheme. So these data nodes represent SQL instances out there, and the P's and the S's, those are replicas. Hey, we had to do our own replica design. We didn't have like always on availability groups to go do these kind of things. So we had to put all that together. We had to partition things in a way to make this work. And then the other thing that's interesting that we decided to do, and it's just, it has its thumbprint today on the Azure architecture for SQL, is at the top hand right, this master concept. So we already knew we had a master database as part of SQL Server. We needed an abstraction layer for connectivity. We'd kind of already started seeing that with things like database mirroring. Like, how do you do abstraction if you have to shift SQL servers for your replica? So this concept of a gateway, which you may have seen and heard about today, we already were playing with. This master node was the ability, hey, go connect to this master, and it'll tell you where to go connect within the infrastructure of all these Azure SQLs. So pretty crazy that the architecture started out looking like this, but a lot of the concepts that you're going to hear about today later on that apply today. And we were already doing that because we were trying to figure out, again, how do we try to build a database service? In fact, Ted Kumert called it a database utility. That was kind of our thinking back in these early days.
Yeah, Bob, this is super interesting. I mean, I hadn't really seen this before, certainly not looked at it closely. But what's interesting to me is, even though the architecture, I think, is different from the architecture we have today, there are, like you said, similar themes, like the fabric, the master, the gateways, these ideas of data nodes that have primaries and secondaries that all are kind of connected. But, I don't think this is the way it is today. So were there challenges with this? Like, why did we move away from this architecture?
Yeah, the elements were there, but one of the biggest problems was something called noisy neighbor. You ever heard of noisy neighbor? Do you have a noisy neighbor, Anna? I don't really know.
Like in my complex? Yeah.
Yeah, in your complex. Yeah, exactly. People do. And again, the concept, if you see this diagram here, was the same thing. Alain could be a SQL Server user for a database and be on the same SQL instance as me, the way we partitioned this. And if he ran this crazy workload, we had no way of controlling Alain to affect my workload, hence the idea of noisy neighbor. So take a look at this diagram. Here's another one that's interesting. This is based on an internal presentation that Peter Carlin, one of our chief architects and one of the chief architects for Azure, and I interviewed Peter as well as part of the book. And I was going through, this is kind of funny how I did this, guys. I was going through old emails. Do you know I have email from 1993 still? Okay, that's pretty crazy. I do. Well, we had Microsoft Mail back then, so I still have these old emails laying around when I was in CSS. And I was looking at this V12, architecture. I'm like, what was the beginning of this V12 architecture? And I found this diagram from Peter Carlin. So I interviewed Peter saying, Peter, remember this diagram? And he says, yeah, Bob, I do. I said, where did Sterling come from? Like, you went from this SQL data service to this Sterling thing. And Peter's like, well, Bob, we had already transitioned to run on Windows Azure by this point, by the time the V12 was coming along. So that we were already doing. So the early fabric and stuff, that all went away. But this diagram, if you see the old service below, represents what we were still doing from this noisy neighbor concept. And I said, well, that's interesting, Peter, but everybody wants to know what Sterling means. And he just started laughing out loud. I'm like, what's so funny? And he goes, well, Sterling was supposed to be named after Sterling with an I, not an E, because there's a famous engine developer named Robert Sterling. Okay, he had developed this famous, well-known heat engine. I'd never heard of that before. And so somebody said, let's use Sterling because we want a new engine to help power the architecture. But somebody misspelled the name in an email, and it's nobody bothered correcting it. So there you go.
What?
Sterling. Yeah, I know. I just love those little stories. So Sterling, if you go ask anybody around the team's been a long time and say, what about Sterling? I think maybe Peter's the only one that knows that this misspelled, probably. But anyways, so the old service below, here's the important part. Notice the cluster represents a cluster of VMs. The nodes, think of these as like VMs. But notice the instance, there are databases from Alain's logical server B that are still competing with my logical server A on the same SQL instance. The noisy neighbor was still this thing. So this Sterling project was about, hey, let's go find a way to make this more predictable. So look at the above diagram. You see here, now, even though maybe instances would be on the same node, and as it turns out, in a lot of cases, they even aren't that anymore. But notice here that no logical server has databases that are on the instance of somebody else's instance. Now, you got some cases here where databases are shared on an instance. As it turns out today in our architecture, most of the time, even smaller databases than Premium, which is the DTU model, will have their own instance. It's very rare, besides things like pools or subcore models and so forth, do we have to even share an instance. So this was a pretty powerful thing. There was another impetus for this, though, and that was we had gotten a lot of feedback from SQL people that even though we're abstracting the instance, they wanted some functionality to be level to them, like dynamic management views, like DMOS weight stats or something. And we couldn't provide that if we shared instances, right, with other customers. We couldn't have that kind of capability, right? So this allowed us to open up some more instance level type functionality, even though you had a database. And of course, it was one great way to help prevent this noisy neighbor problem.
Cool. Wow. Very cool. And so is this the architecture we have today, or is there more?
Well, there's more, and I'm going to let Alain dive into some of that stuff with you to show kind of how we've really evolved, especially in the area like availability and stuff. But this premise that we would not share instances across, we call that the term tenant or customers, was really critical because it really helped us go down this noisy neighbor path. But this wasn't enough, Anna. So we needed some other concepts, though, to make things more predictable. I mean, one of our feedbacks before we were going to this model was customers were not getting predictable performance. Can you imagine you owning a SQL server and you know your performance and you control it? Now you move to Azure, we're going to host the instance and the VM and everything, and all of a sudden you don't get predictable performance and there doesn't seem much you can do about it. That's a problem, right? So what we did was we introduced some interesting concepts. Now, in versions of SQL Server up to this point, we already had this concept called resource governor. You know, a lot of people don't even know that exists in SQL Server today. It's a way to control things like CPU and memory usage amongst users in a SQL instance. So we knew we had this concept, and so we said to ourselves, hey, you know, let's go ahead and further that concept within this service to help provide better predictability. But we need some more things. So Morgan Oslake, one of the PMs on our team that's been around a long time at Azure DB, we started building this concept called a service level objective, or SLO. Okay, and that was to give us certain resource limits on databases to make sure we got predictable performance. You know, how many cores did you get? What was your max DOP that we allowed you to get? How much memory did you get? Those kind of type things. We started giving more predictability to that by the SLO concept. In fact, what's interesting is resource governor was added this concept of IO governance, but it started in Azure. The Microsoft research team with the Azure team to build it internally for Azure database, and then we actually exposed it in the box. And I believe it's SQL 2012 or 14, we exposed that functionality. So resource governor was important. We're running within the Windows environment. And so people may have not heard this, but Windows job objects, it's not a scheduling thing. It's a way to control resources for Windows processes. So we could actually go in now to a SQL instance on a machine, and we could tell the SQL Server executable at the Windows level, you only get this much CPU, you only get this much memory, those kind of type things, and even affinitize it if we need to. We could do that outside the SQL construct, and that was really important because it allowed us to make sure, again, we give that predictable performance and didn't allow a SQL server to take over a machine or something of that nature, right? But there's other things like file resource management, Azure storage limits. We moved to a model now where we didn't rely on local storage anymore. We could do Azure remote storage. That was now something that we added in the mix. And then another thing we found was transaction log rates. Transaction logging can be a very intensive operation for SQL Server. So in order to give that predictable performance, we needed to go put in within the resource governor limits itself, log generation limits, right? To make sure that somebody didn't come in and do some crazy operation that generated so much logging that, number one, we couldn't give people predictable performance, and most importantly, that we could meet a service level agreement. You know, that concept is what's happening now in this V12 timeframe, where you go sign up for Azure SQL, and we have a contract now to say, if you're not available for the time that you know we've promised, you're going to get Azure credit. So things like transaction log rates became really important for that concept. So it's pretty interesting of what we're doing here. Really important to the combination of the Sterling architecture and resource governance. But Anna, that's not the complete story. There's more to this, especially in terms of things like availability. So Alain,
awesome.
Yeah. So Anna, I don't know if it's okay with you, and you've seen some of these diagrams before, but Alain, why don't you talk about, you know, we moved to a new model of how we would do something called service tiers, and we moved in this idea of how we would change availability.
Yeah. absolutely. Thanks a lot. That was a fantastic intro, very interesting history. So yeah, exactly that. So today within the Azure SQL world, we have these multiple different deployment models that exist. And the deployment models are really attached to the underlying architecture and sort of how we provision high availability and scalability in those environments, really. So the ones that were initially within the product was the DTU model, which had sort of standard and premium as sort of the two major SKUs. And then we sort of in the last 3 years introduced the vCore model, which has general purpose and business critical. So even though today I'm going to talk about general purpose and business critical, just understand that standard and general purpose sort of share the same architecture, and business critical and premium share exactly the same architecture. So within the sort of general purpose tier, the easiest way to kind of think about this tier is really for people who are familiar with SQL, is this concept of the failover clusters that we had for SQL deployed in your own data centers, where you could have a compute node that had remotely attached storage, and that remotely attached storage was really where all of your sort of consistency lived. So what customers could do with failover clusters is, if a compute node failed, they could provision a new one and reattach it to that storage. So general purpose has a very similar architecture to that, where sort of you have a remote compute node which the customer connects to, and all of your storage, so where your data files live and where your logs live, are sitting on remote storage. And we have this pool of hot failover nodes that are available within each sort of cluster that we provision in the Azure data centers. So if there is a failure on the customer side, all we do is we just re-provision a failover node and reattach it to your storage. That's how we sort of ensure the availability of that data, so that any transaction that has been hardened to the log can be considered sort of safe from data loss operations, right? The other big thing that's important for availability in this story is how we do our backups. So backups in the Azure world get managed for customers. We run them full backups once a week, differentials once a day, and then transactional backups are done sort of every 5 minutes kind of thing. And these backups are then shipped off to a remote storage account. And the reason that this is important is because in the event of some type of catastrophic failure at a regional level, these backups are stored in a regionally available storage account, which means that those backups get copied into a different region. So even if we had to have some type of major catastrophe where an entire region became unavailable, customers could still get to those backups and restore them from a totally different region, right? And this all happens under the cover. Customers don't see any of this happening. You know, we sort of recover from failures within sort of very sort of limited time frames, all covered within our SLA. So if you look at the SLA that we provide for general purpose deployments, it's 4.9, so it's 99.99%. And I think last time I checked, that sort of entitles us to about 9 minutes of downtime a month, which is a very small window, which means these failures, if they do happen, they have to be mitigated very fast. And that's kind of how we roll through this whole process. The other really important thing in this concept is as Bob mentioned, is this concept of having this sort of a logical entity that you connect to. And this logical entity is really a gateway with load balancers that you sort of hit that control the metadata operations. So essentially, when you think about a failover, normally what would happen in any sort of data center, whether it was your own or another one, if you had a failover to a different node, that would be a different endpoint that you would have to connect to. And that is considered sort of a breaking failure in customer world. So within the Azure architecture, what we do is we keep all of that metadata for the routing into the individual nodes. That sits in sort of the control ring, which is where logical servers and things like that are provisioned, and that will reroute data to the correct physical node. So you have this abstraction of the logical concept of the database from the physical concept of the database, which is really key to how we maintain our SLAs and bring these servers back online in a short amount of time.
Wow,
And,
that's pretty cool. I just want to comment here. So what you're saying is, like, I have some sort of logical server or something that I'm connecting to, and the control ring is taking care of all the routing. So I don't have to build any of that logic as a customer. Is that kind of how it works?
Absolutely, right. So we run a lot of our availability sort of functionality through Service Fabric and that. So, we have the ability to detect when nodes go down, and that sort of routing in the back end is something that you as a customer shouldn't be exposed to. Like it's a complex routing problem. So all you have to concern yourself with is you have this DNS that you've provisioned for a database, and you can continue to hit that DNS. And if something fails behind that DNS, it's our responsibility to bring it back up and do the metadata operations to redirect all your traffic to the new physical node. So yes, we do protect customers from those type of operations.
Cool.
And that's kind of how general purpose works. Now we'll move on to business critical, which is I think this is one that a lot of people will be more familiar with because it's I guess sort of a widely more adopted set of technologies. But behind the covers with business critical, different from general purpose, right? So general purpose is really the database that we recommend, most customers are going to use for their workloads, whereas business critical is really a high-end sort of mission critical type of workload that you're going to run on it. Business critical uses the always-on availability groups technology that was built inside of SQL to ensure availability. So what you have here is you have physical nodes. So you have 4 physical nodes that get assigned. They get added into a replication quorum, essentially. And this is a synchronous quorum for data writing. So if I write data into the primary node, which is the one that I connect to, that data is synchronously committed to all 4 nodes. That way, there's no way for you to have any data loss, because when SQL acknowledges the transaction commit, that means that transaction has been hardened into the logs of all of the replicas in that group as well. So we ensure in this model that customers have very low downtime. And apart from that, all of the business critical nodes, different from what general purpose is doing, are utilizing local SSD. So these are SSD drives that are attached to the local machine. So they are they're more performant than remote disk because you don't have the network hops in between. And they also just sort of have better sort of reliability when it comes to things like synchronous commits that business critical is very dependent on. But similar to what we do in the general purpose architecture, we also have the concept of your backups that get shipped out. The control ring with all the gateways and the metadata for that all are controlled in a very similar fashion. And in the case of business critical, if you have a failure that takes place, what happens here is similar to what happens on-prem today when you have availability groups, is one of the secondaries will get promoted to the primary. And then all we do is there is a metadata operation on the gateway that redirects the traffic to the secondary. So it's a very similar process to what customers are used to when they run availability groups, except this is all sort of highly integrated with the Service Fabric. We have sort of constant runners checking these environments, looking at the sort of the performance of the disks and everything. And with business critical, you actually get a sort of, besides for the higher performance, there are certain configurations of business critical where you can get an even better SLA, which is 4 nines and a 5, which means that 9 minutes of downtime a month that we get pretty much gets half down to 4 minutes. That's how confident we are in this architecture that it can survive these type of failures that would otherwise be sort of catastrophic for customers running on single node deployments. And I think that's a key thing, right, is that even though this architecture looks very complex and it sort of seems like a very complex process, all of this is being done behind the scenes. Customers are not exposed to this complexity, right? Like that's part of the SLA, that's part of the service that customers buy when they buy Azure SQL, is the sort of the peace of mind that their database is safe and the data is sort of being backed up, and we're checking those backups all the time. So this is a big part of what makes Azure SQL sort of such a leap forward for us within the sort of the database space. All right, and then sort of the next one that we're going to look at is
Alain, before you go on, I got to throw this in, man. I can't help myself. I'm just sure. I look at this diagram, and I've been in SQL for 27 plus years, right? And I have supported customers with their deployments. I've been on site with customers with their deployments, And I remember we were first doing these diagrams. I'm like, Alain, you just nailed it. This just happens. You go to the portal, click a button, or you go to PowerShell, click a button, and you just get this. The reason we did this is that we've got some pretty smart SQL customers who have spent their career trying to build this thing in their data center, and it just gives them confidence behind the scene of what we're doing. But put your head around this. You just build the app. You get the listener part without changing the app. It just works with this control ring, right? You get the replicas, you get the availability group, you get a read replica. Your backups are on separate storage, geo-redundant in different regions. Then I can put on top of this something called an availability zone you're alluding to, where I can spread this across data centers. I can even go to like geo-replication or auto failover groups and do this and distributed to a different region. And then behind the scenes, the SQL engine has accelerated database recovery just on by default with this. I mean, and then this SLA thing, when I mentioned the word SLA to people, are like, what do you mean by that? I mean, like, well, we're putting our money where our mouth is, actually, to be honest with you, right? So what we've tried to do, you're right, we've tried to abstract people and not have them worry about all this, but we show these concepts to give you confidence. We're using the power of SQL Server and the Service Fabric and Azure Storage. We're doing this all together. This really is where the power of PaaS comes into play. If I had to pick one thing that I show anybody about the power of platforms as a service, it's this one.
Yeah. And I think the most amazing thing is, and you sort of nailed it as well, is that if you think about a geo replication scenario where customers choose to deploy across multiple regions, in a scenario like that, you actually have 8 physical nodes that are present in that deployment, right? And just the sort of the synchronizing of data movement between that, like before I joined Microsoft, I was also in the private sector, and I tell you, just trying to keep 2 of these things up was a nightmare. So 8 of them is quite a feat, and it's all about making sure that like customers don't worry about things like, am I going to lose data? Is my business going to be out for 24 hours? That's really what we're trying to sort of highlight as the major benefits for choosing these options.
And real quick, I presented this to a customer before, and they didn't know they got a free read replica from this. Like, it comes with it. So they could deploy business critical because they wanted the low latency, right, for their IO and their transaction logging. They wanted the replica design. But remember, you do get a free read replica that you just simply have to use and I've seen Anna demo this, just have to take your app and use the read intent logic, and boom, we're going to use the gateway to direct you to read replicas. Absolutely.
It's a major part of it, because these 4 nodes are all in synchronous sort of commit. That data in the read replica is always up to date. It's always the latest data. So, utilizing those, I mean, I wish I could tell all my customers, hey, listen, use this thing because it's there. A lot of people just overlook the fact that it even exists.
Exactly.
Yeah, I mean, we've talked, if we just take a pause and think about what we've talked about so far today, like you've shown us kind of the evolution of the architectures that we have for Azure SQL. And that alone to me is really cool, really amazing how we've kind of taken SQL Server and figured out how to scale it independently for various customers, keep it separate, keep out the noisy neighbors, all that stuff. And then on top of that, what we're giving for customers just by deploying, you're going to get all this that you both have been talking about for general purpose and business critical is just really amazing. And there's another thing that I really want to get into because it's something that always blows my mind. But we do have a quick question. I think it's pretty relevant to where we are now. So I'm going to take a pause. This question says, I think it's from Urban. They say, if we choose general purpose high availability, who sets up the replication? Should we set it up manually, e.g. creating a main Azure SQL and DR server and set up replication manually, or is there just config? So kind of a complicated question. Either of you feel like you want to take it?
I'm happy to jump on this one. This is something that I have conversations with customers all the time, and I think there is confusion sometimes between what is local availability and what is geo availability, right? And I think this question is a good example of where someone's sort of where those 2 concepts are confused sometimes. So high availability is what we offer all of our customers out the box every time they deploy a database in Azure, right? So if you deploy an Azure SQL database, general purpose, business critical, standard, premium, doesn't matter, they always have some type of high availability. So that high availability protects a customer from a local failure, so a failure within that data center, right? So let's say a drive dies, for example, or a compute node dies, or whatever the case may be. You have these hot standbys that you can fail over to easily. On top of that, within the local context, we have this concept of what's zone redundancy now, which is sort of a new thing that we've introduced, which allows you to protect yourself against a single DC failure within a region, but it's still a regional based failure. So you think about East US 2, for example, as a region within Azure. If you have a database there and something goes wrong in your server, we can recover from that very easily. And that's, like I said, something we offer to all customers out the box. The second concept is the geo concept, which is not something that we sort of deploy by default for customers, primarily because A, there's cost associated to it, and B, not all customers need it. So the geo concept is like, I want to protect my database from an entire regional outage. So again, let's say you had a database in East US 2, you could create a geo replication or geo replicate pair in like West US, for example. And then what you would have is you would physically have 2 copies of that database in 2 different regions, and they would asynchronously commit data or sort of send data to each other. That way, if the whole of East US went down, you could fail over to West US and sort of just carry on. And we provide like a gateway that you can connect to that will redirect traffic depending on failovers. But they're 2 very different scenarios, and sort of they're dealt with very differently from that perspective. But for both of those, you know, customer setup is very minimal, right? Like you go to the Azure portal, you either deploy a database and you get high availability out the box, or you go to the portal and you explicitly choose to set up GeoDR. So we do take the complexity out of it, but they are 2 very different concepts they're important to understand the difference between those concepts.
Yeah,
Alain, I think the key to remember here, look at this, we went back to general purpose. You know, this is like a failover cluster instance, right? Yeah. So the databases are sitting in a shared storage where the nodes can access them if there's a failover. And if you needed to have a copy of it, just like you would in SQL Server, you would have to replicate that. And as Alain just mentioned, you could set up geo-replication to do that. In SQL Server, you'd have to do the same thing if you had a failover cluster instance, right? You just set up an AG yourself or set up even transactional replication. So copies of the database is based on you setting that up. General purpose, Alain's right, we don't by just default do that. But it's a shared copy, where if you go to business critical here now, right, we are using replica designs, and we even protect you with availability zones. So we are using copies here. And of course, one of the benefits, just like AGs, is you get much faster failover. But as Alain alluded to, you can even take this model and geo-replicate it to another region if you wanted to. So.
Awesome. Thanks both. That was a really great explanation, and hopefully that was helpful to Irvin. We have one more question, and then we'll continue on. This one also is maybe a question I'm not sure we will be able to answer, but the question is from Goditis. They say, in US, which is the best region to deploy an Azure SQL resource if you're considering prices, availability zones, sizes, etc.?
I'll start on that one. So, you know, today for Azure SQL, at least, in fact, actually, it's pretty much a statement worldwide. I'd have to double check on our latest, availability, but pretty much what we have available is available everywhere. So to me, regions, and in some cases, there can be some pricing differences. You'll have to go look at that in our pricing calculator, right? But regions are usually about what is best for your application. So imagine a scenario where you're building a very highly available app now, right? Where's that app going to live? Is it going to live in the cloud, not live in the cloud? Where is your data center maybe connecting on premises to Azure? So regions for Azure SQL, at least today, don't usually become a factor of getting a feature or functionality from us. It's really what's best for your connectivity to Azure or for app. Alain, I don't know how you feel, but that's kind of how I look at it.
Yeah, so I mean, that's a good answer. You need to choose a region based on sort of where you're going to be using it. Like, it doesn't help you go deploy a database in like Japan and all your customers are sitting in US, right? Because then you have this massive network latency to overcome. But it is important to understand that like the way we the decisions that Microsoft makes around where we put our data centers and like how they are deployed and things like that is very important to us. That's why we don't just put them anywhere, right? Like there's a lot of considerations about, how we get power from them, natural disasters in that area, water in that area. So there's a huge matrix on how we choose these regions. So all the regions have equal sort of protection from those type of disasters. The costing is purely just based on, the price of running a data center in a specific country versus another one. But in an ideal world, if I was building an app, I'd always try to deploy database and app as close as possible and as close to the users that need to use both of those things.
Absolutely.
Awesome. Thanks both. I really appreciate those answers, and I think our viewers do as well. I want to get us back to the topic. We've talked about general purpose. We talked about business critical. The kind of last service tier, which again, I mentioned this earlier, I just find it so interesting because we basically took SQL Server apart and re-architected it for Azure. So Alain, I'd love if you could tell us a little bit more and maybe give us the inside scoop on how Hyperscale came to be, how it works, and that sort of thing.
Absolutely. So Hyperscale, this is actually an interesting product. I mean, it's we've been working on Hyperscale for probably the better part of 5 years, right? And customers have only really seen it in the last sort of, I guess, 18 months really. And it's been a long journey for us to get to this point. And sort of the big motivation behind why we built Hyperscale was purely because if you think back to what Bob said earlier about the nodes that we deploy and all these things, what a lot of people sort of overlook that gets abstracted, which is probably a good thing on our part, is that those physical nodes are actually servers with cores and memory and disk attached to them. And for the sort of deployments within Azure, the size and specs of those servers will always be the limitation of the biggest machine you can deploy. So you think about our Gen 5 hardware that's out today for general purpose and business critical. The largest machines we can offer a customer has ATV cores, and it has a fixed amount of disk attached to it. You cannot exceed those numbers, right? Because that's physically what the machine is making available to you. With Hyperscale, which was sort of called Project Socrates when we were sort of developing it, the goal here was to build a storage engine for SQL that allowed us to exceed the storage limitations of the physical machines that we were attached to. So the easiest way to kind of think about what Hyperscale sort of as a concept is really it's just a way for us to scale out storage horizontally instead of vertically. By just adding bigger and bigger machines, we can now add storage in incremental fashions without impacting performance or anything like that inside of the database. So Hyperscale as a concept relies on a number of internal technologies for SQL. Probably one of the most important is buffer pool extensions, which we sort of modified for Hyperscale, and it's in Hyperscale it's called RBPX, which is the resilient buffer pool extensions, which essentially was a piece of technology that was released in SQL that allows you to expand your buffer pools down onto locally attached disk, right? And that's sort of a big premise for what we've done with Hyperscale. So Hyperscale really is bringing customers the best of both worlds, right? So it brings you the best of what general purpose has, but also the best of what business critical really has. So with Hyperscale, you can think of this as almost a microservice deployment of a database, where every component of that database has been sort of isolated out into its own compute container in such a fashion that they don't really have dependencies on each other. So customers deploy compute nodes exactly the same way that they do for general purpose or business critical, for example, except in this case, you only get a single node that gets deployed. And different to general purpose and specifically business critical, we don't actually store any of the customer's data on that node. That node is just there to run SQL and execute against the data. You then have this And what that really allows us to do is it allows us to scale out these compute nodes horizontally as well. So you can have more than one compute node. You can have multiple secondaries now that act as both failovers for HA events, but also as readable endpoints for customers. So in the business critical example we showed, there are 4 nodes in that configuration, of which one is your primary, a second one is a readable, and the other 2 are high availability. With Hyperscale, you have 1 primary and you can have up to 4 secondaries, which are all readable as well. So just by that virtue, you can sort of span your workload out significantly. But really where the magic for Hyperscale lives is the page service. So that's this new concept, and really how you should be thinking of the page service is as a caching layer. So on the compute node, we use the locally attached disks, same disk that Business Critical has. We use that disk as a local caching layer for really fast access to data. So it's highly performant, it's really fast, and it uses directly attached SSDs in the node. On the page servers, you have a second caching layer, which is exactly the same hardware as the actual compute node. They're just smaller, and they get deployed in these 128 gigabyte increments. And what we do is each of these page servers have their own compute attached, they have their own memory attached, and in fact, each page server runs a SQL.exe thread on them. So they all have their own cache as well. So what we do with Hyperscale is we actually tier the caching of data across all of these layers so that, customers, depending on what data you access, how you access that data, it's either coming from the really sort of performant local cache or the slightly slower remote cache, which is on the page servers. And then not very similar, but kind of the same concept as what we do in business critical and general purpose, we still keep the backups of your data, except in this case, those backups of your data are the physical data files. We keep those on remote storage where you have highly resilient storage. It might not be super performance storage, but that's fine because you never actually need to access it because you're always hitting one of the 2 caching layers. So that sort of remote storage layer is really there to sort of provide the resiliency and the recoverability that customers are expecting from this product. So different from business critical and hyperscale, from business critical and general purpose, we do snapshot-based backups here, which allows us to do a lot of very interesting things in hyperscale, like constant time recovery. So you can restore a backup irrespective of the size of the backup in a fixed amount of time, because you have all these tiny 128 gigabit partitions that are essentially restoring in parallel at the same time, right? And they're independent from each other. And then just the last thing that's super interesting about Hyperscale is we've also abstracted the log service to be an external thread. So that way, when you're writing data, there isn't this interdependency with the compute node. So the minute the log service has acknowledged the hardening of a new record into its sort of storage layer, we consider that transaction commit. So with Hyperscale, you get higher throughputs, you get sort of better resiliency, especially from your storage layers, than you did with sort of some of the other deployments that you have. And this really is something that we see as sort of a groundbreaking way of thinking about storing data for relational databases. And again, the last thing I'll point out is very important is all of this complexity is hidden from customers. We don't make this your problem. We don't ask you to figure out how to cache this data. We use the same mechanisms that SQL uses today to cache data in and out of its buffer pools to do Hyperscale. So from a customer perspective, it's all completely abstracted. You see this as a database that has multiple files attached to it, and that's all you need to worry about. We worry about how to keep these things alive, how to provide HA within the page servers, and how to serve your data up as fast as possible.
Wow, thanks, Alain. I always, every time I hear you explain this, I learn something new and I become even more in awe of how this product works. Just a quick question before we move on, because I know we only have a few minutes left, but we got a question on LearnTV. They say, would you say that Hyperscale removes the need for Azure SQL sharding for scale, or do you still need sharding?
So no, Hyperscale absolutely is not shard based. Sharding is an interesting process whereby you have to introduce this additional step into query processing, whereby you actually have to resolve which shard your data lives on. The SQL engine in the case of Hyperscale still behaves like an SMP deployment of SQL, where it sees those individual page servers as just being different files. So it automatically knows which data is in those page servers, where to fetch data. So there isn't this additional complexity of sharding data. It's still considered to be one database that's deployed against multiple files. Where those files live, though, is, I guess, not important for the use of that database.
Gotcha.
Yeah,
Cool.
I would throw in that read replicas help a little bit here, right? Because I've seen some people do sharding technologies because they needed read scale. Yeah. And because we have up to 4 secondary replicas for read scale, in some cases for those read workloads, it could eliminate the need to go build a solution like that.
Yep.
Gotcha. Very cool. Thanks so much, Alain. Now, this has been really interesting, but for the most part, we've been pretty much talking about SQL database. I know general purpose and business critical are available also in managed instance, but that kind of brings me to our next topic, because we haven't really talked about managed instance, and it seems like we did so much with SQL database. Why did we invest in managed instance, and what is it underneath?
Yeah, and we focus on the architectures of SQL database so much because they're databases, and we behind the scenes, as we've talked about, are providing an infrastructure that powers so many things like Hyperscale, right? Managed instance was a nickname Project Cloud Lifter for a very big reason, and that is because of 2 things. One, customers wanted instance level functionality like SQL agent or service broker or replication, and we didn't offer that in the abstracted database world. The second is they wanted a private virtual network. And you can see in the top of the screen up here, customers wanted to be able to take on-premises environments with their SQL servers, their environments, and tie that to Azure SQL in a private virtual network. And because we build what's called a virtual cluster, we give you that functionality. We give you a complete SQL instance or more than one instance, so it looks like a SQL instance for that instance level capabilities. And then we give you this private virtual network. Now, we've discovered along the way, if you see in this diagram below here, that for single instances, we're taking up an instance for each VM in this virtual cluster. So we did come up with the idea of a pool, and that limited us, like the minimum cores we could give you, because we do follow that vCore model. That's your only choice. You have general purpose and business critical. Those architectures are the same in this world. But in these dedicated instance world, 4 vCores is the smallest you get. So we had customers saying, I still want an instance of SQL, but I'd like to have like 2 vCores. So we created right now in preview this concept called a pool. And notice here, we can now take multiple SQL instances and put them on the same VM per core. But we're still going to follow those practices we've talked about for resource limitations to ensure that we're going to do that predictable performance. So there's not a lot underneath the coverage you really got to dive into for managed instance. But here's one thing that's interesting. This virtual cluster is what we also call a ring. So this is a little bit explains why sometimes deployment times can be longer. We're deploying our own virtual cluster just for you for your managed instances. And so that's what gives you the capabilities of this private VNet, but it also explains sometimes why it takes a little longer than, say, a database to deploy, where we've got multiple instances and databases sharing in a ring, and we've got the isolation models to go support all that.
Gotcha. Okay, that really helps. And I think, the next thing we want to try to understand, like we've now kind of talked about the different architectures from availability perspective, from managing the service perspective, but what about, like it says here, what about when we have to make updates? We're not updating SQL Server like usual, I'm assuming.
Yeah. So I mean, it's a good question. So the thing you got to remember about Azure is that like we deploy across 60 plus regions globally, and we have millions and millions of databases that sit in production. So it's a very complicated ecosystem. But the team that runs the Azure SQL, sort of the engineering group, we still manage to roll out patches, once a month kind of thing. So this is a very there's a lot of complexity that goes into this because we still have to ensure that we minimize downtime where possible. So we've sort of introduced this concept of what is hot patching, really, where we can sort of patch the code in memory and then sort of just fail over the process without really bringing down the instance at all, right? So this is a very important part of how we kind of patch through these millions of databases without introducing additional complexity to customers. There are some examples when some of the underlying substrates like storage or compute need to be patched as well. And in those cases, we sometimes have to fail over the node to the other one. But I mean, we've covered earlier how we handle those failovers. So from our perspective, those failovers, especially when they're in controlled conditions, happen. We try to always do them when customers are not busy on their databases, but also using sort of those technologies that we described, it's really just a shallow sort of metadata operation for us where, we'll patch the secondary, we'll then fail you over to your secondary, patch the primary, and then sometimes we'll fail you back over to that primary. So, I mean, that's standard procedure about how customers have been doing sort of SQL-based updates for many, many years in their own environments as well, right? And that's just one of the sort of the many features that we do for customers, right? You've got to think about, capacity is a big one. Customers don't ever really get exposed to this, but like, how do we keep these millions of cores and hard drives, and how do we always have capacity so that customers can deploy onto these? And it's interesting, I've done a Microsoft data center tour, and I was quite lucky when I was on my tour there that one of sort of the delivery trucks arrived, and it's really just a big truck full of servers at the back, and they just roll this thing out into the data center and plug it in on the one side, and off you go, right? So this happens pretty much constantly throughout the day, and this is how Azure as an entire product is kind of ensuring that customers have this capacity, and you can rest assured that when you need to go from 4 cores to 40 cores, we have the available capacity to sort of meet that requirement. And that applies to everything we do. Backups, we look after your backups as we've discussed today. We automatically check the consistency of the backups. If you just think about the sheer numbers here, right? Like, a single customer within a 7-day period can produce about 2,024 backups. That's one full backup, 7 differentials, and about 2,020 transactional backups in that 7-day period. Multiply that number by the millions of databases we manage, and all of a sudden you have this huge backup footprint. And you got to check these things. We have bots that run and do sort of consistency checks. So customers don't see this, and that's what we want. These are complex parts of running these systems in your own environment, and we try to abstract that as much as possible for customers so that it's an easy process to use our products.
Awesome. Thanks, Alain. I really like this explanation. We have just a few minutes left, and I want to make sure we get to actually announce something as part of this show, which is really exciting. I'm not sure we've ever done like a launch on Data Exposed, but Alain, what are we launching today, or what are you launching today?
Thanks, Anna. So today we're actually launching, I think the announcement just went out. I got a bunch of emails about it while we were talking, about Azure SQL Insights, which is a product that we just sort of released today. It'll go public preview. So the link down there at the bottom, you can use that to go see. To be fair, I think the link only goes live in like 2 minutes. But I mean, happy to announce this product. And essentially what it is, it's a customer-facing monitoring tool. Like, you got to understand the telemetry, how we gather telemetry, how we surface telemetry, and how we sort of offer customers a monitoring-based product off the back of that is probably one of the most complex things we deal with in Azure, because you're talking about petabytes and petabytes worth of data that we sort of collect and gather and analyze on a daily basis for all of our environments, right? So happy for customers to test this, and thanks for the opportunity to kind of talk about it.
Yeah, I mean, we're super excited about this because what this is going to do is going to give people maybe an easier way to look at some of the things we've been talking about today. Are things healthy? How's performance going? It's kind of going to weave through all the things you guys talked about related to the architectures.
Alain, what I love about this is, having done SQL support my entire life, right, and done diagnostics and things with SQL is you're just, in a lot of cases, you're using the power of what's in the engine already, right? Alain, DMVs, X events, things that the engine already has instrumentation for that SQL Server customers know. You're just exposing this in a way that's actually pretty powerful.
Yeah, we're not trying to reinvent the wheel here. Like every SQL customer monitors their own environment in their own way. So we're just trying to make that as easy as possible for them.
Definitely. Awesome. Well, Alain, Bob, thanks so much for coming on the show today. This has been really fun for me. I've learned a lot. I think our viewers have probably learned a lot. We've gotten a lot of comments and questions. So I think this is a great topic. And, we'd love to have you guys back on Data Exposed Live whenever you want. I think Alain has actually signed up to come on in a few weeks to talk about monitoring. So that's something to stay tuned for. And I know, Bob, I'm sure I have you in the queue as well for something, maybe with we'll see. But, to our viewers, thanks so much for joining us today. I know we went maybe a minute or so over. We are so happy to have you all here. Oh, I just got a reminder that Bob will be coming on the show in 2 weeks with Buck for an Ask the Expert. So stay tuned for more information about that.
I'll write that down.
You didn't know about that, but you'll get an invite soon. But again, thank you all so much for joining us. We hope you enjoyed the show. If you like this episode, please go ahead and give it a like, subscribe to our channel. We're here every Wednesday at 9 a.m. Pacific, and we hope to see you next time on Data Exposed.
Thank you.